Hello everyone and welcome to Module 3, Lecture 1. So in this module we're going to be talking about data visualization using the ggplot2 package. And this first lecture I really just want to introduce the principles of the main function call used in ggplot2 package, which is called ggplot. So it's worth mentioning up front that ggplot2 is a very powerful package and it is used extensively amongst the R community for data visualization. It can do a lot of the features that can be found in base R plot function, and it certainly is a very easy to use tool once you understand the principles of it. So what are such principles of the ggplot function? Well, I think it's first worth calling out that typically a function to construct a graphic or visualization of data does not simply require only one call. So we don't just have a ggplot call. How the graphs are typically constructed is a sequence of code. Essentially we are creating a layered sequence of code where each layer of code is adding a specific feature to the graph. So for example, we might have a layer of code that simply calls the data and the variables that we want to plot. And then we might say, I'd like to have a layer of code which defines what type of graph it is. It might be points for scatter plots, bar charts, box plots. We then might have additional layers of code which define some kind of customizations or fine-tuning to the graph. So for example, we might want to put labels on the graph, titles on the graph, we might want to color code it. So it almost never happens that you would have a graph which is simply a ggplot call. There is a ggplot sequence, which is essentially a layering of code that builds up the graph that we want to produce. So let's just take a look at this kind of generic example here. So this would be a typical example of a ggplot function sequence to produce an example graph. So for example, we would start with the ggplot call where we would input our data set as the first argument, and then typically at this point, although not always, we would introduce this additional function call called AES, which is important for defining the x-axis variable as the first argument and the y-axis variable as the second argument within AES. And essentially I'm going to talk this AES function call in the next slides because it is quite important, but essentially all it's doing is saying which variables in my data, which columns in my data set do I want to use for my x, y or z axes. Okay, so that's the first layer typically in a ggplot function call. The second layer might involve defining what type of graph we want. So I've just left a generic type here, but typical examples that we're going to cover in future lectures are things like box plots, bar charts. So we might have G on box plot here if we wanted to produce a box plot from variables x and y in data set 1. And then we can start to build up additional layers of code which help us customize or fine-tune our graph. For example, putting labels on the x-axis, labels on the y-axis, titles, and there's lots and lots of other function calls that can be layered on top of ggplot to customize the graph the way that we like. And we're going to cover all of those in subsequent lectures. But at this stage, it's just worth recognizing the importance of this layered structure, in particular where we've got a first ggplot call that defines our data and an aesthetic function call, an AES function call, which defines the variables that we want to use. So just to explain this a little bit further, so many of the layers that we'll use in a ggplot function sequence are really just about formatting and fine-tuning, and we really have an endless array of options here that we can choose labels and graph titles and scale the axis and color the axis and a lot more. None of these per se are actually doing anything to the data or choosing or manipulating the data variables in any way. They're simply formatting the appearance of the graph. What's actually probably most important to get a handle on first are those layers which define what the graph is going to look like. In other words, how the ggplot function is going to take the variables in our data set and map them into an actual visualization beyond just things like labels and titles and color schemes. So the first geometry command is really important. So that really defines what type of graph we are going to use. So as I've mentioned on the previous slide, and we'll cover these in multiple lectures, we essentially dictate the type of graph that we want from choosing the type of geometry function. And ggplot offers a lot of different function calls for different types of graphs, and as I said, we're going to cover those in future lectures. So it's very important to recognize that we often need a layer in our sequence call that defines the geometry of our graph. It's the geometry command. And also, just going back to this AES function call that I had on this previous slide here, this is very important, and it actually refers to the aesthetics of the graph. What the AES function is doing is actually asking us which variables do we want to plot within our particular data set. And by doing that, by putting the variables inside this AES function, the geometry command then knows which variables should be used to create the specific box plot or bar chart or whatever. So every graph needs to have this AES command where we tell R which variables. In ggplot speak, what we're actually referring to is the aesthetics, and aesthetics is simply referring to how do we map the variables to the geometries. So which variables do we need to pull out of the data to map them to the particular geometries of the graphs. So geometries, I mean box plots or line charts or bar charts or scatter plots and so forth. So this AES is very important. Whenever we are plotting data, we need to make sure that the variables that we want to plot, for example X and Y, must go inside the AES, because that's the only time really that we're telling R which variables in our data we want to plot. Okay, now you do have a little bit of flexibility as to where to put this AES function call. And what a lot of people tend to do is get it out the way on the first line. So they'll put the very first ggplot call, and then they will input the first argument as the data set, and the next argument is essentially the AES function call, where they define the X variable and the Y variable, and then they'll go on to the other layers and add. So for example, I want to graph a scatter plot, like in this case they would put G on point. Again, don't worry too much about the specifics of the geometry commands. We're going to cover those in future lectures, but just worth bearing in mind that the AES can go in the first function called ggplot. Now what we can also do is pull the AES aesthetic function call out of the first line and put it to a specific geometry, and you'll see that the graphs look identical. That in most cases, putting the AES in the function call for the geometry command is absolutely no different to putting the AES command in the function call for ggplot alongside your data. You get the same graph on the majority of cases. But there is a little subtle difference that is worth bearing in mind. Whenever we put the AES right up front in the ggplot call, so essentially in this example we've got the AES in the first layer, the ggplot function call, what that essentially means is that all of the subsequent layers referring to the geometries that we later plot will use those variables X and Y. So for example, let's say we have a graph that we want to have the plots of the data color coded by another variable. So for example, we might have this variable subject, okay, and we would put in our AES we would have three variables essentially. We would put time as the x-axis, we would put concentration as the y-axis, and then we would have this additional variable subject also inside the AES. And what I'm actually doing here, I'm telling R to color code this third variable on the graph rather than create an extra axis. I don't want a three-dimensional plot. I want to keep it two-dimensional, but use the color coding to add this third variable in my AES. Okay, so then what I can do, I can say, okay, I want to now just add points to the graph, and I actually want to add a kind of statistical smoothing of a line between those points. So I get color-coded points for each subject, and I get all of these color-coded lines. Now, I might not actually want that on some instances, but because I've put my three variables right at the beginning in the ggplot call, those three variables are going to be applied to all geometries. Okay, they're going to be applied to the points geometry and the smooth geometry. And there might be some instances where I don't want that. For example, I actually just might want this type of graph here, where certainly for the points aesthetic, the points geometry, I do want all three variables captured. I want to have color coding my points based on subject, and the x-axis on time, and the y-axis on concentration. But if I'm only interested, for example, in drawing an overall line between all of the data, disregarding the subjects, I therefore do not want my subject variable in my smooth geometry. So the best way to get around that is sometimes to bring your aesthetic function call, where you define the variables for a particular geometry, into the geometry call rather than having it up front. So I appreciate that's a little bit complex. I'm just going to very briefly recap. It's very important that we put the variables that we want to plot into the AES. The AES can either go at the very first function call, ggplot, where we define the data set. In this instance, for example, the data set is called Indometh, and we define the AES with having variables time, color, and concentration. And in that scenario, those three variables will be applied to all future geometries. Okay, so I might want to overlay this graph with additional box plots. So I could have a plus a G on box plot, and always those three variables we carried forward. Sometimes, however, it is a little bit better to define the AES variables in the specific geometries, especially if you want certain geometries to have different variables compared to others. So we're going to expand on this a lot more in the future lectures. We're going to be covering lots of different types of geometries that you can use to construct different graphs. So I hope that was a reasonable introduction to the principles of ggplot function call, and in the next lecture we're going to start using that in a more practical manner to create scatter plots. So I look forward to seeing you then. Thank you.